Okay, for this example for part C, we want to sketch one full period of the graph y is equal to -3 sine 4x minus 2 pi over 3. And we want to find and label the following, so we want to make sure we're okay with the amplitude. We also want to make sure that we're comfortable with the period, any phase shifts, and also we want to make sure that we find the 5 critical points too. And then we're going to sketch it. So based on all this information, we're going to sketch it. Let's start off with the amplitude. Again, notice we have a number in front of the function. So that's telling us we have an amplitude of the absolute value of -3, which is 3. Also, because it's negative, the constant term in front of sine is negative. So we know that this is going to be a reflection over the x-axis. I'm just going to put it over here on the side to remind myself when I sketch the function, there's going to be a reflection over the x-axis. Okay, so we have the amplitude. For the period, the normal period of the sine function is 2 pi, but now we see that there is a number attached to our variable, and there's a 4 that's attached to it. So our new period is going to be 2 pi divided by that value, or 2 pi divided by 4, which simplifies down to pi over 2. So now we have a period of pi over 2. Okay, so a normal period goes from 0 to 2 pi. So I hope you can see that this is a horizontal shrink rather than a horizontal stretch. Again, normally we go from 0 to 2 pi. So it's here. Now we're going from 0 to half a pi. So we have a very big horizontal shrink within the context of this question. Let's talk about the phase shifts. And so really what we're going to do is now instead of having a period of 2 pi, now we have a period of pi over 2. Not only do we have that period of pi over 2, but now this minus 2 pi over 3 means we're taking that pi over 2 and shifting it to the right 2 pi over 3 units. So we do have a phase shift. And in order for us to figure out exactly what it's going to look like, we're going to find, instead of sine starting at 0 and ending at 2 pi, we're going to find that new starting point, the new ending point of sine. And again, the way that we do that is we set the argument, and this is the argument over here. We're going to set the argument equal to 0, and that's going to help us find our first endpoint. So we have 4x minus 2 pi over 3 is equal to 0. So let's do this. Let's add 2 pi over 3 to both sides of the equation. So that gives me 4x is equal to 2 pi over 3. And then we're going to multiply both sides of the equation by 1/4. To clear out the coefficient of 4, you could divide both sides by 4 as well. And so we have 2 pi over 12 divided by, you could simplify, you can pull out that factor of 2 from each one of those. So that's telling us now that we're starting at pi over 6. So again, instead of starting at 0, because we have that phase shift of 2 pi over 3 on our period of pi over 2, we're going to start at pi over 6. So let's start right over here. Let's remind myself that our starting point is pi over 6. It doesn't matter really where it is as long as it's to the right of 0 because it's positive. So that's our starting point. Now our ending point we find by setting the equation equal to 2 pi, because that's our normal ending point is 2 pi, but now we're going to have a new one. Okay, so I'm going to do this first. We're going to set it equal to 2 pi. Let's just right over here, we're going to start, we're going to end. We're going to set it equal to 2 pi, so we're going to start off doing the same thing we did before. I'm going to add 2 pi over 3 to both sides of the equation. And we have 4x is equal to 2 pi plus 2 pi over 3. Let's combine these on the right-hand side. That's the same thing as saying, let's see, 6 pi plus 2 pi all over 3. And that's the same thing as saying 4x is equal to 8 pi over 3. And same thing, we can do what we did before. We can multiply both sides of the equation by 1/4 or divide both sides by 4 to clear it out. And this is telling us that we have an ending point at 8 pi over 12. Pull out the factor of 4 from both of those, so this will give us 2 pi over 3. So we start at pi over 6, and we end at 2 pi over 3. Okay, so we have our starting point and we have our ending point. And so what we're doing here is we know what two of our 5 critical values are. We know critical value 1 and critical value 5. Let me move this over just to give it a little bit more space. Let's do that. And that was 2 pi over 3. And then this is critical value number 5. So remember what we need to do is we need to find these other 3. Let's go 1, 2, 3. And how we do that is we take the period and we divide it by 4. and then we constantly add it to the starting point until we get to the end point. So we have a period of pi over 2. Let's divide that by 4. That's the same thing as saying pi over 2 times 1 over 4, or pi over 8. So that's telling us that we're going to start at pi over 6 and constantly add pi over 8 to it. So our starting point's pi over 6. Let's add pi over 8 to it. Let's see, we have an LCD of 24. 4 pi plus 3 pi over 24, and that gives us 7 pi over 24. So this is giving us our second critical value. Second critical value is 7 pi over 24. Let's continue with that, and we take 7 pi. Let's find the third critical value. Let me just put a 2 here to remind ourselves of the second one. For the third critical value, again, I'm going to take 7 pi over 24 and add pi over 8 to that again. We have an LCD of 24, so it's 7 pi plus, let's see, times 3 pi. That gives us 10 pi over 24. And we can reduce it if we divide both the numerator and denominator by 2. That's the same thing as saying 5 pi over 12. So that's our next critical value, is 5 pi over 12. Okay, critical value number 3, and we just need critical value 4, and then we'll check and make sure critical value number 5 makes sense. So here's 10 pi over 24, again, plus pi over 8, and that's the same thing as saying 10 pi plus 3 pi over 24, and that gives us 13 pi over 24, which can't be simplified, so we're just going to keep that as 13 pi over 24. So this is critical value number 4. Now we already have critical value number 5. You don't have to do this. I just want you to make sure you understand why it makes sense. If we take 13 pi over 24, and if we add pi over 8 to it, we're going to get 13 pi over 24 plus 3 pi. And that's going to give us 16 pi over 24. And if we reduce 16 pi over 24, if we can pull out the factor of 4 from each one of those, we can pull out a factor of 8 from each one of those, we're going to get 2 pi over 3, which tells us that that's our endpoint. And if you take a look over here, we knew that 2 pi over 3 was our endpoint anyway. Okay, so here are our 5 critical values. We have an amplitude. Let's go back to now the amplitude, which is 3. So that means we're going to max out and we're going to min out at 3 and negative 3. But we're dealing with sine. And remember that sine starts at 0. And also remember that we're going to reflect this over the x-axis. So normally we do something like this, right? Oops, sorry about that. Normally we do something like this. So do. But because we're reflecting it over the x-axis, now we're going to start at 0. We're going to go down. We're going to go back to 0. We're going to go up, and then we're going to end at 0. So this is one complete period of y equals negative 3 sine 4x minus 2 pi over 3. And again, keep in mind, we have our critical values. We included our amplitude. We made sure that we reflected it. This is what one period of this function looks like.